Hello, good afternoon, all. Today, let us continue with few more problems on even and odd signals. How to sketch, how to determine the even and odd components of any given signal. Okay, we have already solved few of the problems. Some problems were in the form of some equations, and one or two problems we have seen how to, if a signal is given to you, okay, the sketched signal, how to find the even and odd component of that. The basic idea behind this even and odd component, it is these two equations. You should remember this. Even part, how to find x of t original signal, add the signal with the reflected signal, and then amplitude half it. This is even part. For odd part, take the original signal, subtract it from the subtract the signal with the reflected version, and then divide the amplitude by half. So these two are the basic equations to find the even and odd component. So we have already seen this first problem. The second problem, this was dealt in the last session. Today, let us continue with one more problem. Let me just zoom a little bit so that it looks a bit bigger. Okay. This is a signal x of t. If you observe, the signal range is between -2 to 2. Okay. How to find the reflected version of the original signal? So in order to get the reflection, what I will do, I will divide the complete signal into parts. Okay, three blocks I will divide. This is one pulse, this is 1 second pulse, this is the third pulse. So for this, let me just go for the reflection. The first pulse is like this. Okay, if you take the reflection of this first pulse, it looks like this. Okay, the reflection of the first signal, that's why it is like this, first part. Then going for the second pulse, if you observe the second pulse, it is here between 0 to 1. What will be the reflection of this? Reflected version of this, that's why it is like this. Okay, then coming to the third version, the third part of the original signal, it is something like this. Between 2 to 3, I have a pulse like this, negative amplitude pulse. If I take its reflection, see, the reflection means whatever positive time is there, see here, positive time has become negative, right? Negative time has become positive. So just change the time, put a negative sign in front of them. The range is now between -2 to -3. Sorry, -2 to -1. The same pulse, it appears like this. Okay, the reflection of this is like this. So between -2 and -1, the third part exists. So this is how these three parts of the signal have been drawn like this: 1, 2, and 3. This is the reflected version. Once you find the reflection, the next step to find the even and odd part is you add both, you subtract both. First, let's go for addition. If I add these two, let's go from the leftmost. You check, the signal starts from -1 here, but here observe the signal is starting from -2. So 0, some signal, okay, some signal is present here. The same signal, see here, 0, here it is 0, 0, 0, 0, nothing, till -2, nothing. After -2, observe, here it is 0. Here you have some negative amplitude pulse, this pulse, okay, this pulse, this is 0, this is 0, no amplitude. But here if you observe, this is 0 and you're having some negative pulse here. So 0 plus of minus 1 is the same, right? Minus 1, the same is continued. After that, you observe this pulse has the amplitude 1, this pulse has the amplitude 1. 1 plus 1, 2. That's why drag it and extend up to 2. So this amplitude is 2. Then between 0 to 1, time check, amplitude is 1. 1 plus 1, again you 2, extend it. After this, between 1 to 2, check it, you have a negative pulse, minus 1. Here nothing, 0. So minus 1 plus 0, same, minus 1 is continued, minus 1. Okay, this is how we add the signals. Now what is the next step remaining? Last step, we have to divide the amplitude by half. Check the amplitudes here. Here the amplitude is minus 1. If you divide it by 2, this will become half. That's why you see only half of this. Okay, it's not complete. Half, complete one will be this much. Half will be this much. See, only half I have drawn, and that is minus 0.5. Then the amplitude here, it is 2. Divide the amplitude half. That is 2 by 2. It will be 1. So this complete pulse whose amplitude is 2, it is now the amplitude with the value 1. So this is how even a part of the signal x of t is drawn. Similarly, let's go for odd part. To get the odd part, we have to go for subtraction. Okay, I hope it is visible to you. I have to zoom out a little bit. It is not fitting in the window. Okay. For odd part, I have to take this signal and second signal. Okay. Let's not get confused. I should not consider remaining. Now, to get the odd part, we have to subtract. So for subtraction, let's go for this. It is 0. The second signal is also 0. 0, 0, 0. Nothing. After this, here you have 0 amplitude, here you have minus 1 amplitude. So 0 minus of, because I am subtracting, minus of minus 1. You will get minus of minus 1 is plus 1. That's why if you observe minus 2 to minus 1, you have a plus 1 amplitude. After this, check, this is 1 amplitude, this is 1 amplitude. 1 minus 1, 0. So 0. Then add, sorry, subtract 1 minus 1. 1 minus 1, 0. Same 0 line is continued. Then amplitude here you observe it is minus 1. So minus 1, minus 1. Both are minus 1. So let me check. Oh, sorry. I did not, I should not take this. This is the common mistake. Minus 1, here it is 0. Okay, first two signals, minus 1 and 0. I have to take subtraction. Minus 1 minus 0. You will get minus 1. Observe the pulse is on the negative side with the amplitude minus 1. So this is the subtraction of original signal and its reflection. Now to get the odd part, finally I have to divide this complete amplitudes by 2. Half the amplitude. The pulse width here, it is 1. Okay, see, 0 to 1. Divide this somewhere here at the center I will get. So the pulse I have reduced in size with the pulse amplitude half, 0.5. This also pulse, this complete pulse is minus 1, just half of this. So I will draw only half of this pulse, minus half. Okay, this is how the odd part has to be sketched. I hope you understood. This was a very simple problem. Earlier to the earlier problem, compared to the earlier problem, this looks bit simple. Any doubts, you can put it in the chat box. Let me continue with the next problem. Till then, Okay. The question now, it is in discrete. See, discrete, it is very simple. You know, for any of the operations, let it be any scaling, shifting, because each point has got certain amplitude, you have to shift this. For a continuous, it is bit difficult, I feel. So this is the question given x of n. The range is, you can check, the amplitudes are 1, 1, half and 1. The range is between -1 and 2. Between this, some 4 amplitudes are there. This is 1, this is 1, this is 0.5 and this is 1. So each time has got certain amplitudes. I have to find the even and odd component. So to get the even and odd, I have to first sketch the x of n is there. I have to first go for reflection, then go for addition of those two and subtraction of those two. Finally, amplitude should be divided by 2. Okay, let's go for that. First, I have to go for the reflection. The reflection is very easier here. 4 samples are there. So first starts with the leftmost. What is the amplitude here? It is 1. So what is time? -1. Put a negative sign before it. Minus of -1 will be +1. So at +1, I will draw this amplitude 1. Then go for the next. At 0, 0, 0, it remains the same. No reflection. Then at 1, amplitude is half. So put a negative sign before the time, it will become -1. So at -1, I will draw half. Next, at point 2, time 2, the amplitude is 1. See, positive. Put a negative sign before it, you will get -2. At -2, draw this amplitude 1. So this is how each point, put a negative sign before the time, positive time will become negative, negative will become positive. Observe here, -1 has come to 1. 1 and 2 have come to -2 and -1. Times have got negative signs. So once you get the reflection, go for addition. When you add, let's start from the leftmost. This second signal is starting at -2. Here it is 0. 0 plus 1. Plus 1. Then you have 1 here. 1 plus 0.5 is 1.5. At 0, observe 1 plus 1. It is 2. Then 0.5 plus 1. 1.5 again. Then amplitude is 1. Here it is 0. So 1 plus 0, 1. Okay, this is the addition. After that, after adding, what we have to do for even part, I have to go for half the amplitude. You have to divide the amplitude by 2. So this is very much easier here. Just simply put divide by 2 on each time. So this is 0.5. See, if you divide it comparatively, assume that if this shows 1 unit between 0 to 1, half will be this much, right? Half will be this much because it is comparatively center point, right? The length should be this much only. If there is 1 unit like this, don't draw this much and write half because it should be sensible. आप इसको अगर एम्पलीट्यूड 1 दिखा रहे हो, 0.5 जो हाफ रहेगा उससे कम रहना चाहिए. ओके, इसका हाफ रहना चाहिए. सो कंपैरेटिवली योर आंसर शुड बी सेंसिबल इनफ. ये लेंथ को आप हाफ करना, हाफ करके यहाँ पर आप मार्क करो कि 0.2 है, देन इट लुक्स सेंसिबल. दैट्स व्हाई इफ यू सी, यहाँ पे ऑब्जर्व कीजिए आप, द एम्पलीट्यूड यहाँ पे 1 है, इसका हाफ मैंने ड्रॉ किया है. कंपैरेटिवली सही तो लगना है आंसर. ये 1 है तो ये 0.5 है एम्पलीट्यूड. जब 1.5 है, 1.5 इज हाउ मच? 3/2, राइट? 1.5 को डिवाइडेड बाय 2 करो, कितना होगा? 0.75. 0.75 आप देखो हाउ मच लेंथ आई हैव यूज्ड. अगर ये 1 है, ये 0.5 है, ये 0.5 है, 0.75 कितना रहेगा? ये 0.5 और 1 के बीच यहाँ कहीं पर आएगा पॉइंट. तो उतना ही मैंने ड्रॉ किया है, 0.75. ये 2 है, 2 by 2 will become 1. 1.5 divided by 2 is 0.75. 1 by 2 is 0.5. This is the even component. Now let's go for the odd component. To find the odd component, I have to subtract the signals. I hope it's not visible, right? Okay. Fine. So in order to get the subtraction, take this first signal, take the second signal, you have to subtract. So from the leftmost, if you observe, till -2, you don't have anything. So till -2, nothing. At -2, check it. Amplitude 0, amplitude 1. So 0 minus 1 will be -1. So I have drawn it -1. Then amplitude 1, 0.5. So 1 minus 0.5. You will get 0.5. It is plus 0.5. Plus 0.5. 1, 1. 1 minus 1. Sorry. 1 minus 1, 0. So at 0, nothing. Then half 1. That is 0.5 minus 1. So यहाँ पर negative sign आ जाएगा. Minus 0.5. Minus half. See, downwards. Then 2. Sorry, at 2 you have amplitude 1. 1 and 0 amplitude. So 1 minus 0, you will get the amplitude equal to 1. So this is how the different amplitudes look like. So compared to the continuous time signals, operations, discrete times are a bit easier. After this, once I subtract, I have to go for dividing the amplitude by half. So just divide all the amplitude values by half. So 1 will become 0.5, 0.5 will become 0.25, 0.5 will become 1.25, 1 will become 0.5. This is how we go for odd part of the given signal. Okay. If you observe the next question, any doubts you can ask me. Okay. This is the given question. Here they have not given you the drawing directly. They have not given you how the signal looks. Instead, they have given you this equation. You have to first draw x of t and then you have to go for even and odd components. So if you go for drawing, you have already seen some of the elementary signals, exponential signal, how to draw, u of t, you know how to draw. So let's multiply and let's try to find out. Okay, in brief, I'll tell you. E to the power of minus t by 4. I can write this like e to the power of minus 1 by 4 raised to t. And E is how much? 2.718, I guess, E value. E to the power of minus 1 by 4. Use your calculator. You will get this approximately 0.7788. You can check it. You can cross verify it. Raised to t into u of t. Okay. After this, what is the next step? I have to draw this. Let me just show you how to draw this. Okay. Substitute t as 0. I will start with that. At time 0, I will get the amplitude 1. Now, if I substitute t is equal to 1, that is, I'm now talking about the right hand side. T equals to 1 means 0.7788 raised to 1. So, somewhere here I will get. Then put t equals to 2. 0.7788 से थोड़ा कम value आएगा. If you can check it from the calculator, 0.7788 raised to 2. You will get some lesser value. Like that, keep on substituting t equal to 1, 2, 3, 4, like that. You will get an exponential curve like this up to infinity. Okay, this is your exponential term. Then what is your second signal? It is u of t. U of t, you know it. On the left hand side, nothing. At 0, there is a transformation between 0 to 1. This is your u of t. Now try to multiply these two signals. If you multiply these two, check 0 on the left hand side. Sorry, not 0. Still this will extend. Sorry, I did not put the negatives values, right? Similarly, try to put all negative values of time also, right? Because t range, they have not given you anything. You should consider all values. So if you substitute t is equal to -1, -2, -3, all negative values, you will you can try. Okay, you have already seen the exponential signal, how to draw. You use your calculator, you observe the signal is something like this. The signal is something like this. Okay, some amplitudes are like this. Now if you if you multiply these two signals, here you have some signal, there is a signal here, but here it is 0. So 0 multiplied by anything, nothing. We don't have any value at the output. Now the constant 1 amplitude is multiplied by this signal. So 1 into any value, say 1 into a, 1 into b is a, b, c only. So the same signal will be continued on the right hand side. That's why finally when you draw your x of t signal, it looks like this. Amplitude at time 0, it is equal to 1, and it decreases up to infinity. So now we have drawn x of t. The next step is we should go for even and odd components. Okay, x of t is there. Go for the reflection. What is the reflection of the signal? If this is your signal, reflection will be like this, right? So the reflection I have drawn it here, and it extends up to -infinity. Now add both the signals. See, you have 0 here, 0 plus some signal, the same signal on the left hand side, and you have a signal here plus 0, you will get same signal. 0 plus any value, the same value will continue. This is your addition of original signal and its reflection. The amplitude is 1. Now how to get the even component? Even component can be found by half. You have to divide the amplitude by 2. So this amplitude will become half. That's why comparatively draw a lesser amplitude than this and mark the amplitude as half. This is the addition. Similarly, go for subtraction. If we subtract two signals, I hope it is visible. No, it's not. For odd, okay. If I subtract, see here on the left hand side, it is 0, and there is a signal here, see, exponential signal. So 0 minus of this. So whatever signal you have here, you know, this signal, it is vertically, you have to draw the reflection. It's like this. Okay, the reflection of this, because it is minus, amplitude should be negative. जो सिग्नल आपका ऐसे दिख रहा है, अभी इसको ऐसे ड्रॉ करना पड़ेगा आपको, वर्टिकली सिमेट्रिक नहीं, हॉरिजॉन्टल सिमेट्री ड्रॉ करनी पड़ेगी. इफ द सिग्नल बिकम्स माइनस ऑफ this indicates positive exponential, this indicates negative amplitudes exponential. Okay, then on the right hand side, check, you have a signal like this, 0. So the signal minus 0, the same signal will continue. See, the same signal will continue here. On this side, the reflection of this, I'll show you. Right hand side, no issues. Directly this value plus this, sorry, minus this value, this signal minus 0 will be same signal. But here it is 0 on the left hand side, 0 minus of this. So minus, how to draw the negative exponential? Negative exponential will be the reflection of this. ये जो amplitude 1 है अभी आपका -1 पे आएगा, minus e. That's why it looks something like this. Okay, this is the subtraction. After subtracting, check the amplitudes. They are 1 and -1. So finally, to get the odd part, half them, divide. So the same signal I have drawn with the half amplitudes as the maximum values. This is how we go for even and odd components. Okay. Any doubts, you can ask me in the chat box. One important note here. This is your question paper problem. Okay, in the question paper they have asked that this is the given x of t. You have to find the even and odd parts. Okay, they have not given you how the signal looks. They have not given you directly the signal. Instead, some equation is they have given between 0 to 1. This is the equation. Between 1 to 2, this is the equation. You have to draw the signal. Okay, if you try substituting between 0 to 1, if you consider this, between 0 to 1, if you take the points, assume take t equals to 0, you will get, let me show you. Suppose I take t equals to 0, I'll get this. Now, say t equal to say 0.5. 0.5 lies in between 0 and 1. So take 0.5. 0.5 into 2. T is 0.5. 0.5 into 2 is how much? 1. So I'll get 1. And take t equals to 1. 2 into 1 will be not 1 exactly. It should be less than 1. No, suppose if you take 2 equals to t equals to 1, what value you will get? Because if you take equate, two values are there, two signals are there, two equations, 2t and 4 minus 2t. So suppose t equal to 0.5, I have taken, it looks like this. And suppose if t equals to 1 means, here see the equation, 1, it applies to this also and this also. If you take this t equals to 1, t equals to 1 means 4, okay fine, 4 minus 2. At t equals to 0, let me just do it one more time. T equals to 0. At t equals to 0, 2 into 0, 0. Then t equals to 0.5, 2 into 0.5 is 1. T equals to 1, 2 into 1, something here. This is 1, this is 2. I'll join it. Somewhere here I'll reach. After that, t equals to 1, one more equation, t equals to 1, 2 into 1 is 2, 4 minus 2 is 2. I'm here itself. Take 1.5 in between 1 and 2, 1.5, 1.5 into 2, 3, 4 minus 3 is 1. I will come here. Then t equal to 2, substitute t equals to 2, 2 into 2 is 4, 4 minus 4 is 0, 0. So this signal x of t, it looks like this. The equation looks like this. Amplitude is 1 and 2. See, we have already solved this kind of problem. See, we have already solved even and odd part, but amplitude यहाँ पे 1 था maximum. But जो आपका जो question paper problem है, it is amplitude is maximum, it is 2. So please try solving this problem as an assignment. It is a question paper problem. Okay. Two more assignments are there, and these equations which it is visible on the screen to you, these are the equations which you need to prove for even and odd signals. Again, take this as an assignment. Anyhow, I'll be sharing the document with you. If you don't understand anything, you can ask me anytime. You have to prove that the integration of a signal, it is equal to 2 times the integral if the signal is even, and the integration is 0 if the signal is odd. You have to prove this. In order to prove this problem, the identity, you have to go for the basics of your integration. Calculus you might be thorough with. You have studied the basics of integrations, some properties of integrations. You have to use those properties and solve this problem. So anyhow, I'll be sharing this document with you. This is also an assignment to you. Prove that two identities, x is even, x is odd. Okay. So with this, we have completed even and odd signals. Still many problems are there. So anyhow, please practice. Please try to solve the question papers. In the next session, we will be continuing with periodic and non-periodic signals. Okay. See, we have already seen continuous time, discrete time, even and odd. Next is we should go for periodic and non-periodic. Still this one and energy and power we should cover. So in the next session we'll be starting with periodic and non-periodic signals. Any doubt in this even and odd, you can come and ask me anytime. I'll be available in the college. You can ask me the doubts, you can clarify the doubts, or you can even contact me through the WhatsApp.